Welcome to the Stormsurf video surf forecast for the week starting Thursday, February 7th. Looking at significant wave heights for the North Pacific Ocean, we see a broad area of seas at 20 up to 26 feet over the North Dateline region, all the way down into the Central Dateline region, all pushing east. This from a storm previously in the far West Pacific, probably the strongest storm we've seen in quite a while. And then we see some other sorted non-significant areas of seas in the East Pacific Ocean, but generally the pattern here is not favorable for storm production. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their path. We're looking for a trough. Just like that right there, a little dip in the jet that helps create a counterclockwise flow aloft and down at the surface. And that is the hallmark of low pressure in the northern hemisphere. And of course, low pressure generates wind, wind generates seas. Seas, as they radiate away from the fetch area, produce swell. Swell, when it hits your beach, produces surf. All right, so you'll notice we're starting at the 54-hour forecast. The last time this model updated was back a couple days ago. There is an issue, and you'll notice this if you go to the site. All the weather models are old and getting older by the moment, and that is not going to change anytime soon. Basically, what happened is NOAA has moved to secure servers, which is a good thing, but the tool we use to build the images doesn't support it at all. There is somebody working on that, but I don't think they're going to make it anytime in the near future. So we're going to have to move to a whole new platform and write a bunch of code and do a bunch of other things. So it's going to be a while, in the period of weeks probably till we get these models updated. Fortunately, the wave models are still good, and that's what most people use. But if you're chasing snow and chasing precip, unfortunately, all those tools we built are going to get old and age out. It's just going to take a while to get there, but we do have a path forward. We figured out how to do it. It's just going to take time. All right, so right now, Jetstream consolidated in the West Pacific, but not strongly so. You almost see it almost looks like it wants to split there, but the jet's holding together, feeding this little trough here. But then, of course, as has been the case for the past several weeks, the jet is splitting just east of the dateline. The northern branch pushing up into Alaska, but notice this is a new trough developing here. Now, not really good for swell production, but sucking cold air down from Alaska, get this circulation here. That will set up another round of precip for the whole U.S. West Coast. Meanwhile, the southern branch pushes south over Hawaii and then into Baja. Right, let's put this into motion, see what we can get out of it. The trough kind of pinches off as we get into Friday. Jet remains consolidated, but weakly. Notice wind's not very strong at all here. And then here comes the first trough down the coast. Actually, let's go back and take a look. There it is. See it pushing into Northern California and about dying there with the jet coming back together, pushing on over Central California. This is on Saturday and Sunday. Another trough starts falling south, doing a very similar thing. Notice the two paths of the jet consolidating right over Central California, pushing on shore. I guess one could call that a atmospheric river situation, but really what you want to see is a consolidated jet, not sort of this split thing sort of weakly coming together, but the whole thing just blasting right on shore. Also notice winds building to 190 knots over Japan on Monday, and a sort of a broad trough kind of carve out under Kamchatka, but not really doing a whole lot. And then we get into Tuesday. That's the end of the model run, and still another trough setting up off the U.S. West Coast, falling south. One would think that at some point here, with the active phase of the MJO building down here, north of wherever the active phase is, that's where all the jet stream energy is. But one would think these winds should even be stronger, and they should be pushing east and causing this split to collapse at some point. But we'll see. Right now, that is not the situation. Let's take a look down at the surface and see if we can see how the jet stream is reflecting its situation on the surface. And it's pretty obvious here. Consolidated jet running along here, splitting like that. Between the split, you get high pressure. There we go. Here's our low pressure system as of Thursday, a 1020 millibar low, not particularly strong. And here's the remnants of the trough or the gale that was on the dateline. We'll roll this out a little bit. You can see not a whole lot of support for storm development or swell production. But notice strong high pressure, 1036 millibar high on Friday, pushing south. Here's Hawaii. Major Kona wind event is expected. Also on Friday, the first in a series of lows pushes along the California coast. Here we go. Gale starting to develop. Now, this is a cutoff gale because the jet's doing up here, down here. So this is just sort of something in between, not getting a lot of jet stream support, but winds 50 knots. Forecast pushing somewhat towards Hawaii. Saturday, gale developing off the U.S. West Coast. This is great for surf production for Hawaii, but seeing how it's so close to the islands, you go up basically every 5 degrees north is 300 nautical miles, so 600 nautical miles north of Hawaii. This big old fetch aimed right at the islands. Just a wind event, if anything, if there ever was one, this is it. And then the storm again off California. By Sunday, the gale starts fading north of Hawaii, but very close. Another gale starts developing off Japan. Weather continues for the U.S. West Coast. Now notice here, 55, 60 knot winds and a gale pushing off Japan, lifting northeast very fast. By Monday, pushing over the North Dateline region. The low still circulating over Hawaii, but much weaker, only producing 20, 25 knot winds. So we get into Tuesday, things settle down a bit. Another gale trying to develop towards the dateline. Another low off of Northern California, and low pressure still continuing north of Hawaii, raking Kona north winds over the islands there. Right, let's go take a look at the wave models. So the good news here is the wave models are running. They are up to, this is actually hindcast data, but the models are running. They're up to date, and that's good news. What we're looking at here is back on Monday afternoon, a couple days ago, gale developed off the Kuril Islands, built. It was supposed to have at one point up to like 52, 53-foot seas, but the best it ever eked out was 44-foot seas. But then this rebound that happened Tuesday night into Wednesday morning, broad solid area of, say, 38-foot seas up to about 41-foot, and pushing well towards the islands. But now remember, there's a low developing here. By the time that swell arrives, things will get pretty ugly for the Hawaiian Islands. All right, so here's where we are at current. Let's move forward. And here we go. And notice the wave model is valid as of 12Z Thursday. Thank goodness. Small miracles do happen. Anyway, so that system fades out. We're looking to see what, then here comes the developing system north of Hawaii. There was also, we'll keep our eye on the West Pacific. Here you go. 41-foot seas within I'll pull that away. There you go. 41-foot seas within 600 nautical miles of Hawaii and aimed right at Kauai and Oahu. Large, raw, jumbled swell is the expected result. If you have property on north-facing shores, west-facing shores particular, right on the beach, take some effort to secure your property now. Pretty large raw sea state is expected, and you can see right here by 18Z Sunday, 30-foot seas hitting directly into Kauai and Oahu. You don't want to be on the beach, you don't want to be in the water, and you don't want to be in a boat in that area at all. All right, small gale develops. We saw that. Actually, it's a storm with 44-foot seas, but all the energy pretty much aimed to the north, maybe sideband swell into the Pacific Northwest, and it's up there. Remember, the jet stream is doing this big split, so it's directing storms away from the U.S. West Coast to the north. This is the only area right here favorable for gale production at all. Anyway, roll this out. Here comes another gale on Tuesday, pushing towards the U.S. West Coast, 20-foot seas, but again, too local to be of particular interest. And where are we on Thursday? Seas continue north of Hawaii, still 23-foot seas. Pretty impressive indeed. And then a local gale, another one on Friday or Thursday night, a week from now, supposedly, with 28-foot seas, anywhere from 20 to 28-foot seas. Likely a storm event for California again, and a new system developing out towards the dateline. So what's the short of this? Basically, we've got this well-entrenched pattern, big old dip in the jet in the West Pacific, massively split in the east. But the good news is the split is actually retracted from the coast, drawing energy. The jet's coming up here and down like that. It's just sucking energy from Alaska. This is like a La Nina pattern, really. You get this sometimes. A lot of cold air, not really swell-producing storms, but cold air and wind pushing down the coast. Great for making low snow levels and copious amounts of dry snow for the Pacific Northwest down into the Sierra. A quick look at local winds for California and for Hawaii. Again, with aged data, doing the best we can, and it's only going to get worse several weeks out. But anyway, you see, the wind machine starts for California. The wind machine starts for Hawaii as you get into Friday. California spared. Hawaii, look at this, 25, 30 knot north winds, and it's holding in the 20 to 25 knot range. Weather pushing down the coast. Look at this. Oh, wow, look at that. 55 knot winds just north of Hawaii, supposedly on Sunday, and dropping towards the islands, fortunately fading. Still, 35 knot winds expected into the north shores of Oahu and Kauai at a minimum, and maybe Maui. Not good. Sort of a wind machine. When you get this high pressure setup, 1038 millibar high, it just creates a lot of wind, and you can see it for California and Hawaii. So really, the surf situation, not so good unless you're south of maybe Monterey Bay, and certainly Southern California have better local wind conditions. Precipitation forecast, looking mainly at California, knowing that this is age data, gives you a rough idea of timing. First bit of weather coming in Friday night, not particularly heavy for no snow for Tahoe until you get into Saturday. Then the Sierras start a little push, a stronger push as we get into Sunday. Rain down the coast there, and snow Sunday night into Monday morning. Then things back off a little bit. Then here comes the next system tracking right down the coast. Whoops, and we missed it there. But more snow Tuesday into Wednesday. Quick look at snow forecast dashboard, Squaw Valley. Per this, about 30 inches of snow for the weekend, this coming weekend. Not so bad. The snow levels, mightily impressive. Here's the base of Squaw. Here's the top of Squaw. Here's where the snow levels will be, well below the base, down at 3,000 feet, something like that, and holding for the foreseeable future. Great situation in terms of temperature for snow, but high winds expected with the passage of the front, 60 knots or so. So that would create a fair amount of upper mountain closures for sure. Looking at Kirkwood, about the same picture, maybe 32 inches of snow accumulating over the weekend. Again, very low snow levels. That's not an issue. Wind, again, 60 knots or so, so that would be a concern. And then finally, Mammoth, because these are storms coming from the north to the south, most of the precip gets wrung out before it ever makes it to Mammoth. Yeah, maybe 10 inches or a foot, something like that. Snow levels, not an issue. Way below the high 8,000-foot base, just not enough precipitation. Wind, again, in the 60-knot range. All right, let's go take a look long-term what's going on with the MJO, and of course, possibly, maybe, probably not, El Nino. As usual, we like to start looking at winds across the equator. This is the West Pacific here. This is the East Pacific here. The equator's right there. That is New Guinea. The dateline's right there. And the U.S. West Coast up here beyond the north range of this image. But these winds are from the TAO buoy array, series of buoys strung across the equator, used mainly for monitoring El Nino, but we can also use them to monitor the MJO. All right, winds, 5-day average winds. These aren't actual winds at this moment in time, but a 5-day average, solidly from the east, the whole way across the Pacific until you get about to the dateline, and then the winds appear to be northeast, but in some cases from the west. Interesting. So if you have a slackening of trades over here or out and out westerly winds, that's clearly a sign of the active phase of the MJO. And if that prolongs or happens long enough, it's a sign of El Nino. All right, anomalies. So basically, these are what the winds are over the past 5 days, but are they stronger or weaker than normal for this time of year? That's what this is, anomalies. Differences from normal for this time of year. You look here and you see the arrows are kind of like, it's the east-west component we're looking for. And we don't see anything. So this is basically normal in this region, but you get from about Hawaii and west of there, and you see westerly arrows. Those are called westerly anomalies. That's a clear sign of the active phase of the MJO. So the MJO travels from west to east on the equator, goes the whole way around the planet. But when you get westerly winds here, that's kind of like a sign of low pressure, and low pressure is a sign of the active phase of the MJO, and the active phase of the MJO also produces precipitation, and that helps basically push energy up into the jet stream. So if you remember from the jet stream charts over the West Pacific, the jet was consolidated, and then right about when it got to the dateline somewhere, it started splitting and everything fell apart. Wherever the active phase of the MJO is, north of there and south of there in summer months, is where the most energy will be in the jet and the greatest potential to produce storms. All right, what have the winds been doing the past 5 days, or at least for in the recent past? All right, so there's South America, there's Central America and Mexico, there's Australia, New Guinea, there is the equator right there, and the dateline running right there. And there's this area right in here called the Kelvin wave generation area. From 170 west, 5 degrees north to south of the equator, just draw a little box in your mind. And when you have westerly anomalies in there, that's the area that's great for producing Kelvin waves. And what's a Kelvin wave? Well, that's in the water, but basically these westerly winds take warm water that's here, creates a ball of that warm water, pushes it to depth, and that warm water bubble, known as a Kelvin wave, travels all the way across the Pacific, then erupts off the coast of Ecuador, creates a warm water pool off of Ecuador. And if you get a couple of these Kelvin waves in a row, and it takes like 3 or 4 months for them to traverse the Pacific, but if you get them back to back, then you can start to develop El Nino. If you get enough warm water here, that starts creating precipitation here. That starts affecting the jet stream, and basically it takes the jet stream and starts sucking the consolidated jet stream and starts sucking it east, and that feeds the storm track into California and imparts energy to the jet, creates surf. It also creates weather. All right, so past 5 days, westerly anomalies. You can see them, orange and yellows, the arrows out of the west in the Kelvin wave generation area, and you can just sort of eyeball down here. Westerly anomalies nonstop for the past 5 days. Sure looks like the active phase of the MJO. All right, what's the forecast? Well, so this chart is a little bit of past history and future forecast, but, okay, so this is the whole planet on one chart. The dateline runs right up the middle. California is at like 122 west, so over here. Kelvin wave generation area between these two tick marks. So if you go up here in your mind's eye and you see the oranges, those are westerly anomalies. So we've had westerly anomalies in the Kelvin wave generation area basically the whole month of January. Yeah, a little bit of easterly anomalies trying to build in, but really didn't. And been pretty solid the past week and a half or so. Supposed to back off for maybe 2 or 3 days and then start building very solid in the heart of the Kelvin wave generation area. In other words, the active phase of the MJO is in effect not particularly strong, and we see that in that the jet stream, yeah, it's consolidated north of where the active phase is, but not much more than consolidated and not particularly energetic. But it is supposed to be building strongly, and that should feed the jet stream and feed the storm track as we get about a week out. All right, let's look a little further out into the future, 2 weeks out, for example. All right, so this is outgoing long-wave radiation forecast. What's that mean? Basically, the amount of sunlight reflected off the ocean surface. When you see blues, that's negative anomalies, so that means there's a lot of clouds here. When you see orange, that's positive anomalies, no clouds, and that means a lot of sunlight reflectivity. A lot of sunlight reflectivity means the inactive phase of the MJO, high pressure. The blues, low pressure, the active phase, the MJO. You can see this pretty quickly looking down for the next 2 weeks. This per the statistic model, blues or low outgoing long-wave radiation, or the active phase of the MJO holding on the dateline 2 weeks out. The statistic model, the dynamic model, far more energetic and positive, suggesting a very strong active phase of the MJO building on the dateline 2 weeks out, while a very strong inactive phase builds over the Indian Ocean. If you have been reading the papers at all, you're hearing about drought in Australia. You're hearing about crushing heat. That's all because the inactive phase has set up a sort of permanent base here over the Indian Ocean maritime continent. And when you hear about fires in Australia and drought in Australia, that's typically associated with the development of El Nino. We don't see El Nino right yet, but it kind of smells like something's trying to get going. Let's take a look at phase diagram charts, another way of looking at where the active phase is and how strong it is and what it's going to do for the next 2 weeks. So this is, assume you're looking down on the North Pole. The MJO travels from west to east over the Indian Ocean, over the maritime continent, to the West Pacific, across, or actually under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. And the active phase goes round and round. It keeps doing this cycle. The heavy dot is where the active phase is. It's in the West Pacific. The further away from this circle, the stronger it is. So modestly strong. The forecast per the ECMF model is for it to collapse and meander over to, we'll say, western North Africa 2 weeks out from now. The GEFS model suggests the active phase building in, we'll say, near the dateline region or so, and getting significantly strong. When you're up in this range, this far away from the circle, that's a strong MJO, and then just sort of hanging in that area, say dateline to the Central Pacific sort of thing for the next 2 weeks. This is kind of interesting. The 40-day upper level model. Okay, so the greens are areas favorable for precipitation, the active phase, the MJO. The oranges, not favorable for precipitation, the inactive phase, the MJO. So there's South America, Mexico. There's the equator. Dateline, roughly right around in here. And New Guinea, you get the idea. Very, very strong area favorable for precipitation, one would assume associated with the active phase of the MJO, and that slowly working its way into Central America through about March 4th. So if there was ever a window for storm development, precipitation development, it's the basically the next 3 to 4 weeks. That's it. Followed by the inactive phase of the MJO, developing in the West Pacific, about the middle to late February, and it too making its way into Central America through March 19th. So that's when the storm track would falter, and then a far weaker MJO pattern, active phase, developing in the West Pacific beyond that. And yet another model, the CFS forecast. This goes out 1 month. Looking at past history first, same sort of deal. The date line runs right down the middle of the chart. Kelvin wave generation area between these two tick marks. That's really what we're looking at. See this preponderance. The reds are westerly anomalies. I mean, it's just nonstop westerly anomalies since November. So that's what was making everyone think, the El Nino is developing. The black lines are the active phase of the MJO. So active, inactive, active, and you see that's when westerly anomalies are their strongest. Inactive, building active phase. All right, look at this. This is pretty impressive if this holds, and the model's been suggesting it pretty strongly for a week and a half now. Here's we are today. There's the date line. This is the Kelvin wave generation area. Very strong active phase of the MJO, major westerly wind bursts forecast starting about 3 days from now, and to continue nonstop till about the end of February, and pushing, look at this, into the U.S. West Coast, we'll say February 24th or 5th, something like that. If there was ever an opportunity for a major weather event for California, this would be it right here. This week, somewhere around the, say, 23rd through about March 1st, something like that, March 3rd, something like that. Major westerly anomalies, certainly supporting storms capable of producing surf, but likely also producing a lot of wind and weather. All right, and one more. And this is the 3-month model, and you can see this bullseye just staring you down. It's pretty obvious. Okay, but we'll go through it here. Kelvin wave generation area between these two tick marks. Future forecast from the top up. I mean, you can't say anything other than a major westerly wind burst event forecast for the dateline from about February 10th or so through about February 24th, something like that. Let's overlay the MJO. There's your active phase of the MJO. Not as pronounced as in the other chart. In fact, not even as strong as this event back in January and December. Still, major westerly wind event forecast. All right, active phase of the MJO through about, we'll say the end of February and pushing fully into the U.S. West Coast, followed by the inactive phase of the MJO. So when you get these stronger MJO pattern, that's typically not a sign of El Nino. Okay, El Nino tends to just squash out the MJO completely, and you get westerly wind events. They're nonstop, but it's like you have this continuous active phase of the MJO. But when you see strong active to strong inactive to yet another strong active MJO event starting, April 4th or so into May, this is not a sign of El Nino. All right, so let's overlay the low-pass filter. Now, this is even more interesting. So we thought El Nino was going on here. So you see the black lines. What's that all about? We'll call it, the solid contour is a bias favorable for low pressure, centered right over the dateline, has been all year. That's what was making everyone think El Nino is developing. And here's your dotted contour, your high pressure bias over the Indian Ocean. All right, now the interesting thing was, yes, the third contour line disappeared. And we thought we were into El Nino, and then right when El Nino would have been doing something, it just like faltered and died. The interesting part now is starting February 12th or so, third contour is to come back. Low pressure is supposed to start building. So typically when you get an El Nino, if you're going to get it and it's going to be decently strong, it'll start in like the late January, February time frame. And if it's decent enough, it'll hold the whole way through spring, summer, into the following fall and peak out around December time frame. So this model suggests El Nino tried to get going, and right when it was supposed to peak in December, it faltered. But it hadn't given up. It's kind of like going to wake up again and maybe give it another shot next year. And we're talking, we're in early part of February, and this model is suggesting that maybe, just maybe, 9 months from now, we could still be in a pattern favorable for storm production and surf production and weather production relative to California. That's a bit of a leap, but it's possible. We've been talking about a 2 or maybe a 3-year, not a El Nino, but a low-grade El Nino thing, and that's actually a good thing because it really helps set the atmosphere momentum going in favor of storm production. And this winter, it hadn't been optimal or anything, but it's been better than the past couple of winters. There's been some solid, large surf. It's kind of been raw, but there has been surf, and there has been rain, and there has been weather, though officially we're not in El Nino. All right, enough of the MJO. Let's talk about what's going on in the ocean. So, there's multiple dimensions to El Nino. So here's the West Pacific. Here's the East Pacific. This is data from the TAO buoy arrays. Here's the anchor lines on the TAO buoys themselves. The X's are sensors, temperature sensors on those anchor lines going down to 300 meters, so 1,000 feet deep. From this data and using a little bit of modeling, you can try to connect the dots and build a profile of what's going on temperature-wise. So basically, we had a pocket of 30-degree centigrade anomalies. That's pretty warm over here in the West Pacific. It's actually gotten weaker in this week's run and has been getting weaker for several weeks. 28-degree isotherm line, still holding pretty stable. If anything, moving a little east. Was at like 165 last week. It's at 162.5 now. If you can really be that accurate from this model. And the 24-degree isotherm line still pushing into Ecuador. Basically, this is saying that we have warm water pushing the east. But let's go look at anomalies. Differences from normal for this time of year. And here's the thing that sticks out. Not particularly, obvious or anything, but plus 3 degree centigrade anomalies. So we've had westerly winds in the West Pacific here for a month now. It's no big surprise that that's taken warm water that's here over the maritime continent, pushed it to depth, created a bubble of warm water. That's called a Kelvin wave. This Kelvin wave is pushing east. And notice there was another Kelvin wave here. It's Kelvin wave number 2 of the year, already pushed onshore. Kelvin wave number 3 developing and starting to follow the same track. It's still 2.5 months out from reaching the coast here, but still, it's a Kelvin wave, and we'll take that. It's better than to have, this 1 degree centigrade negative anomalies, probably associated with the upwelling phase of the Kelvin wave cycle. So basically you get warm water pushing in, little bubble of cool water, then more warm water, and that's how the cycle goes. You'll see it in another chart here in a minute. Here's another model using the same data, basically painting the same picture. Yes, what is this? 1, 2, 3, 4, 5, 1, 2, 3, 4. 4 degree anomalies centered under the dateline, pushing off to the east. Now notice this shows a complete collapse of warm anomalies along the coast of Ecuador with cool anomalies upwelling. That's not a surprise. Upwelling phase of the Kelvin wave cycle. A couple of weeks that'll be gone, and the next bubble of warm water will start arriving in Ecuador. Also notice warm anomalies leaching off of New Guinea in that area, the maritime continent, feeding into this, maybe, possibly the start of another Kelvin wave, especially if that major westerly wind burst develops in the West Pacific as forecast a couple days from now. Sea level anomalies, so this is South America, Mexico, Central America, New Guinea there, equator there, dateline there. What do we have? 5 centimeter anomalies. So what's this? This is from the JASON-2 satellite. Strip out all the wind waves, strip out the swell, strip out the tides even. And you have a 5 centimeter bump on the ocean surface. What that means is, what causes that actually is warm water at depth expands, so it creates a little bump on the ocean surface. Cool water at depth contracts, creates a depression on the ocean surface. 10 centimeter negative anomalies here. And we know that there's cold water there. So all this does is sort of correlate with the other data that we're looking at from the TAO buoy array and saying, yeah, there's warm water here, developing Kelvin wave, pushing east, upwelling phase of the Kelvin wave cycle here, cool water for the moment. And then to put it all together, upper ocean heat anomalies, okay? So basically it just sort of shows you where the warm water is and the cool water. This is the West Pacific here, East Pacific here, going back in time. March, cool water. Last year, this time, we were in the fading remnants of La Nina, cool water in the East Pacific. Kelvin wave number 1 meandered across from a westerly wind burst back in February a year ago, and that sort of wiped out La Nina, and that warm water pushed into Ecuador in the June-July timeframe. Kelvin wave number 2, very strong, much more solid, traversed the Pacific from, we'll say, September into, December-ish time frame, 3 months or so. Kelvin wave number 3. We see that under the equator right now, under the date line at the equator right now. Small Kelvin wave. Oh, there's your, better yet. Kelvin wave, upwelling phase of the Kelvin wave cycle. There's your cool pocket. Kelvin wave number 2, upwelling phase of the Kelvin wave cycle. Kelvin wave number 3 developing. It'll take 3 months to get here, so maybe April-ish time frame. And maybe Kelvin wave number 4 developing, associated with the strong westerly wind burst forecast a week out. And that all kind of smells like El Nino when you just have Kelvin wave after Kelvin wave. Now, these haven't been particularly strong. They've been kind of half-hearted, but we'll see. I mean, it's certainly a way better pattern than La Nina, where you have no Kelvin waves and cool water sitting here. So this is all feeding the jet stream in some way and feeding the storm track, and we're seeing evidence of that in California, in Hawaii, and there's been continuous surf, just not anything particularly off the charts yet. All right, so we've talked about the atmosphere. We've talked about ocean at depth. Let's go talk about the ocean at the surface. All right, sea surface temperatures, anomalies, differences from normal for this time of year. And typically in an El Nino pattern, you want to see a warm kind of like, I'll call it an anvil or a triangle, going from about here into here and into here. And we really haven't seen this past year. And you really want to see warming building along the South American coast. Again, from Kelvin waves erupting in this area, get this buildup of warm water, and then the trade winds start taking that warm water and pushing it off along the equator. Right now, yeah, we have warm temperatures along Peru, and actually this looks better than it has at any point so far in this El Nino cycle. But we also have this big pocket of cooler upwelling waters that have developed, very localized, limited area. We think that will be short-lived. We also have warming along the Mexican coast and Central America, out off the Galapagos, but then things kind of fall apart here. Not a lot of warming here. The official El Nino monitoring region, the Nino 3.4 region, from 120 west, right here, 5 degrees north and south of the equator, out to 170, so right there. You don't see a whole lot of warming there. Light warming at best. The Nino 1.2 region, right in here, more warming there. No clear sign of El Nino, but certainly no sign of La Nina. This pocket of cooling right here, a little bit troubling. It's been here literally the entire year. This is the last fading remnants of La Nina. Not gone yet, still there. So kind of putting a damper on things. The trend for the past 7 days, off of Peru, Chile, warming. You can see that there. That's pretty good. Not in the official El Nino monitoring region, but sort of a sign of general warming. Also warming from the Galapagos out to about 130 west, something like that. But there's also a little bit of cooling here. There's that little finger of cooling there. So kind of a mixed bag, generally trending in favor of warming, but not markedly so. The overall picture here, again, warmer than it has been off the Galapagos, warmer than it has been off Peru, chillier off of Ecuador. Let's go look at the trend line. Here's the Nino 1.2 region. This is up along Chile, Peru. Temperatures, 3/4 of a degree, 0.730 above normal. Actually falling a little bit, but you can sort of see it's up and down. This is a rather noisy area. If you were to draw a line through this, say, averaging about 0.5 degree above normal, maybe a little bit more, maybe a little less, something like that. It's the official Nino 3.4 area, that area, 120 west to 170 west, 5 degrees north and south of the equator. Today, at 0.609 degrees above normal, 0.6 of a degree. And you can sort of see if you drew a line through this, at least from here on, yeah, it's been averaging about 0.5 degree above normal. El Nino, officially, at least the temperature, ocean temperature component of it, 0.5 degree above normal for more than 5 months. And we're probably there, let's see, November, December, January, working our way into February. So that's 4 months. And we're probably pretty close to, we'll be pretty close to 5 months by the end of February. We'll probably officially reach the threshold for a bare minimal El Nino, but nothing like really significant. And certainly nothing, well, we'll talk about more than that, but there's more to it than just the ocean temperatures. Specifically, there has to be an atmospheric component. You can have all the Kelvin waves in the world and the westerly wind bursts and the warm water building up off of Ecuador into the official Nino 3.4 region, but the atmosphere above it has to respond. Right now, we're looking at the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. If pressure is lower over Tahiti, then the index will turn negative. Well, today it's minus 7.59, but if you look back here, it's been basically positive for a month. It was actually more negative consistently back in January than it is now. And that, remember, the 3 contour line low pressure bias on the dateline region, well, we're not seeing any of it here. The 30-day average takes some of the noise out of it, and you can see it's been hovering basically around 0. Today it's 0.30. No big deal. The 90-day average, if this were negative down around minus 10 or 15, then you go, hey, El Nino, what are we at? No, we're at plus 2.58. So really, I'm just looking the whole way down here. No, it's been hanging at +2 to 3 for a month now. No sign of El Nino. Here's the 30-day average graphed out. You can see if it was down negative, that would be El Nino. If it was positive, it would be La Nina. We're looking back January, April of 2017, and we were just hanging around neutral, a little bit La Nina-ish here in late 2017, even into 2018. Then here's when we thought we were starting to go into El Nino. See, we were down at -8 and 10 or 11 in some spikes here. These downward spikes are the active phase of the MJO, but not enough to keep it solidly in that territory. In October, we kind of rebounded neutral to almost positive. Here where we are today, just basically dead neutral. No sign of El Nino in this index. And then there's the ESPI index. Instead of measuring differences in pressure between the area north of Darwin and pressure north of Tahiti, it's precipitation, total precipitation amount. If you have more precipitation than normal here, the index goes positive. What's the index today? -0.09, or about as neutral can get, right in here. So, yeah, maybe there's warm water here, and warm water creates evaporation, and evaporation supposedly creates precipitation. But then this index is saying there's no more precipitation here than there ever is. Standard neutral fair. So, what's this all mean? Well, we have the underpinnings of what could be El Nino. We have a consistent pattern of westerly wind bursts and Kelvin waves, and we think we have another strong one building right about when it should be building if you were going to develop an El Nino for this coming 2019 time period. But we have no sign in the atmosphere of El Nino developing at all, at least on the official forecast and all that. But the interesting thing is, we do have storms, we do have surf, we have snow, we have all that, so it's kind of a mixed bag. It looks like it's moving towards El Nino, but we're not there. But the good news is, clearly it's not La Nina. We have turned the corner from last year. No sign of La Nina. Yeah, there's surf. Yeah, there's snow. So we're in a good place. The question is, what's going to happen a year out from now? If you look at the year-long model, and we didn't show that, we're kind of running short on time. Basically, it's showing no different than what it's been showing. Basically, an ongoing warm pattern through the entirety of 2019. So, at a minimum, I'd say we're neutral, maybe biased towards El Nino, but not officially in El Nino yet. But that's a good sign. I mean, that creates surf. I mean, that's good sign for surf production for this summer and into next fall and into next winter, assuming everything sort of continues on the same path. And maybe, just maybe, if we get lucky, the atmosphere will couple with the ocean, and then we will really get an El Nino. Of course, the downside to that is, once you have an El Nino, you get a La Nina following it, and then everything falls apart again. So we really don't want that. I'd rather have a 3 or a 4 year slightly warm event that never reaches El Nino threshold, and that gives us all that we need for surf and snow production. So anyway, that's it for this week. We'll do it again. So let's see, not this coming weekend. It'll be a week and a half. We got some things going on that'll make us unavailable to do the forecast on Sunday. But the following Sunday, we will do that. And at some point, we're going to really need to start buckling down and trying to figure out the model situation, the weather models, and replumb all that. So that'll keep us busy. Anyway, thanks for watching. Do it again next week. Same week out, week and a half. Same time, same channel. Thanks.